Hello, everyone. In the last lecture, we have gone through adaptive thresholding technique. And before that, we have also discussed about, means we started discussing thresholding with global thresholding. And in the last lecture, we have compared the performance of global thresholding with adaptive thresholding. And we came to know that adaptive thresholding is a, means give better results for such images where lighting variations are there. Now, let's come to today's discussion topic, that is autosys thresholding. First, I am going to discuss the concept, and after that, I'll go for practically implement this autosys thresholding technique in OpenCV using Python. So you all are with me, Dr. Divyajyoti Bora. Well, in global thresholding, we use an arbitrary chosen value as a threshold. You know that we have taken a constant value, and based on that value, suppose that maybe 125, 127, whatever it is, that threshold value we have considered arbitrarily. Now, in contrast, autosys method avoids having to choose a value and determines it automatically. So this is the plus point of autosys. Say we consider an image with only two distinct image values, that is a bimodal image, where the histogram would only consist of two peaks. A good threshold would be in the middle of those two values, right? So means we have to consider a threshold value which will be the middle of these two peaks value. Similarly, autosys method determines an optimal global threshold value from the image histogram. So this method, this autosys method, is going to use the histogram of that image to find out those peak values, and based on those peak values, it determines a threshold value. Now, in order to do so, the CV threshold function, this function is used where CV dot trace underscore Otsu, remember this function, trace underscore Otsu, is passed as an extra flag. And the threshold value can be chosen arbitrarily. This algorithm finds the optimal threshold value, which is returned as the first output. So one threshold value is chosen arbitrarily, but after that, when it actually analyzes the histogram, then it will find out the optimal threshold value, and that will be the first output. Like in the first case, say you consider 127 as the threshold value for the global thresholding. Then in the second case, when we apply autosys thresholding, there will get this output, right? In the third case, the image is first filtered with a 5x5 Gaussian kernel to remove the noise. Remember, autosys thresholding, you please note it, that autosys thresholding we use in such cases where noises are there in the image. And about the noise in its different types, I'm going to discuss in detail with practical implementation in the coming lectures. So don't worry about that. Right now, you just remember, you just noted that autosys thresholding is very helpful when such noises are there. Right. So in this case, here I'm using the linear image. We all know about the linear image, right? But you first choose a noisy image and apply this algorithm. You just need to change this line of code where you will pass your noisy image, and everything will be same. Okay. Let me discuss about the code. This is the code. I'm keeping it in blue color, bold, so that you can easily take a screenshot and you can go for implementing it by your own. So import CV2 as CV, import numpy as np. Remember, in this case, numpy may not be included. Okay, so it's on you, but it's not necessary, right? Okay. Well, so this two line is okay. Then from matplotlib, import pyplot as plot. Then this will be required to show the plotting of the images output. Then image cv imrit. This is the part where that original linear color image is there. Then I am converting it into grayscale with this CB imrit grayscale function. Suppose if image is not found, then this message will be shown, like file could not be read. Check os.path.axis. Well, let's come to the main thing, global thresholding. Now here, CB threshold image, that is the original image, 127 and 255. 127, we are using the global value, right? And 255 is the maximum value. Then CB trace binary for the global thresholding. Then the value will be stored here, right? TH1 is the means output image, RET1. Now let's come for the Otsu's thresholding. So here, image, original image, cb.threshold, under that I am passing it, image 0 to 255, whole range I am passing 0 to 255. Then cb trace binary plus cb.trace Otsu. So Otsu's thresholding after Gaussian filtering. Then for this filtering purpose, for this Gaussian filtering purpose, we are using this Gaussian blur, right? I told you, na, 5x5 Gaussian kernel is used to remove the noise. So this is one we are talking about, exactly 5x5, right? Image 5x5, 0. Then that will be stored in a blur. So next, CV threshold blur, that is the Gaussian filtered image, right? 0 to 255 as it is. Then CB trace binary plus CB trace Otsu's. So you have seen three cases. First one is the normal global thresholding. Second one is the also Otsu's thresholding as it is, means no Gaussian filtering is done. But third one is the after Gaussian filtering, then we applied the Otsu's thresholding. So all the images are kept like this, TS1, TS2, TS3 separately. Now images will be plotted. Images, image 0, threshold 1, image 0, threshold 2, blur 0, threshold 3. Then titles will be like original noisy image, histogram will be shown. Then global thresholding value is 127. These are the messages you can type your own. Now, original noisy image, histogram, Otsu's thresholding. Then Gaussian filtered image, histogram will also be shown there. Then Otsu's thresholding. Now, how many values are there? 3 values are there. So for that, we are using what? A for loop, I in the range of 3. Right? So we have to divide this plot into 3 cross 3, right? So subplot, for that means subplotting of division of the plot, we are using the subplot T, then I cross T plus 1, plot image so, then images I cross T, gray. Then similarly, we are using X ticks and Y ticks for the coordinates. Similarly, for the subplot 2, subplot T, like that. So it's very easy. You carefully observe this. And this hist function is used for what? Showing the histogram. In every case, see, in every cases, we are showing the histogram, original noisy image, Otsu's thresholding image, Otsu's thresholding image for the Gaussian filtered image. In every cases, we are showing the histogram. Clear? So each and every line of this code is clear now. Now let's try to implement this in OpenCV. I'm going to open my spider from Anaconda. So you do your open one. Well, you have that how we have discussed the code. Now just type the code as it is. I have typed here, everything being discussed. Now let's run this file. See, it's coming. See, it takes few seconds because it's a long, it means functions, so complicated functions involved, right? That's right. Now, here in the plots also, you can see the output. Or if you want to see the output here in the console itself, you go here and just you unclick this one. Okay. See, original noisy image. This is the histogram of the noisy image. Then thresholding with 127 as the threshold value. Then noisy image being filtered with, no, first Otsu's thresholded with directly Otsu's thresholded, and then this is the output image of the Otsu's thresholding. But then after that Gaussian filtered image, then we have applied Otsu's thresholding. So clearly in the third case, we are getting a better result. See? Histogram also you can analyze. This is the original histogram. Although here the noises presence is very less. But if you consider a noisy image, then you will get a better result. So I suggest that go for a noisy image and apply it. Then only you will understand that what is the difference in output you will get for these three different thresholding approaches, right? One is global thresholding, another is Otsu thresholding, and another is, last one is Gaussian filtered plus Otsu thresholding. Okay, histogram can be analyzed accordingly. Well, then I think I have discussed everything, but still if anything missed or if you want to know more, just let me know through a comment. That's all for this session. Thank you. Bye-bye.